Thank you, Alon, and thank you everyone for being here. I'm Logan Scott-Deter, and I focus on research to improve bicyclist safety. As many of you may know, bicycling has grown in popularity a lot over the past few years. This is awesome because there's environmental benefits associated with it, economic benefits, and health benefits associated with this increase. One of the downsides is the crash rates that occurs. In 2020, there was about 40,000 bicyclists that were injured due to crashes with motor vehicles. Just under 1,000 of these actually ended up resulting in a fatality. One of the most common crash types in these scenarios are at signalized intersections, and it's called a right hook crash. Imagine you're operating a vehicle, you're looking to turn right at an intersection. You might look at cars coming in front of you, you might look for cars on your left. But it's often that people forget to look in their blind spot and check for that bicyclist that could be on the right side. These are the scenarios where a right hook crash occurs. It's when a right-turning vehicle collides with a through-moving bicyclist. We as transportation engineers have ways to accommodate this, and one of which is through roadway design. We looked at different roadway treatments, the first of which is called a mixing zone. This is an intersection where the bicyclist and the car have to figure out how to merge together and coordinate that zone with one another as they approach an intersection. The second type we looked at is called a bike box. This uses green pavement as well as a little waiting area for bicyclists at the intersection to help distinguish their presence and help make them more known to other users at the intersection. The third design we looked at is called a bicycle signal. This gives bicyclists their own lane and their own signal, and it dedicates when they can move through the intersection safely. So you might be wondering, how did we study these designs? Well, we took these images that I just showed you, and we developed 3D models in a simulation environment. We made these designs, and we asked participants from the area around Corvallis. We recruited 40 participants total to come by and ride on our bicycling simulator, shown here. They had a wide range of experience. They had a wide range of ages, from 18 all the way up to 74 years of age. And they rode this bike for about 20 or so minutes, and while they rode, we gathered tons of data, tons of stuff related to their position, their speed, their acceleration, all of this, and what they were doing in relation to other cars and conflict vehicles in the environment. All at the same time, we also wanted to focus on what they were looking at. So we recorded their eye movements. We strapped them up with glasses, and we recorded what they were looking at while they were riding. Were they looking at the signal? Were they looking at the cars, the buildings, the environment? All of these things were recorded throughout that 20-minute ride. These are an example of the different scenarios that we looked at. So the different AOIs that we looked at when they were focusing their visual attention. The one we were most interested in is that yellow box there on the left. That's the conflict vehicle. So when they were approaching an intersection, how long were they looking at that car? Were they aware of its presence, and what were they doing in response to it? Bunch of numbers here. I'll highlight the important parts from this data. What we found is that in the mixing zone scenarios, they were focusing on that car for about 3 seconds more than the other treatment designs. They were very aware of its presence, they were very aware of the risk that it presented, and they were ready to respond if that car made a turning movement in front of them. In the bicycle signal scenarios, about 3 seconds less than the other treatment designs. They weren't focused on that car. Maybe they were more focused on the bicycle signal, maybe they were focused on other aspects of the roadway, but they weren't focused on that potential conflict. And if that made a random movement, they were not ready to respond in that scenario. In addition to these eye-tracking movements, we wanted to assess how comfortable the riders were in each of the scenarios. So we asked them, what was the level of discomfort in these different treatment designs? And 30 out of the 40 individuals said they did not like the mixing zone. About 3/4 of the people did not like this design, whereas only 5 individuals said they felt uncomfortable in the bicycle signal. This is a big difference. And remember, I also told you that our simulation was tracking where the riders were positioning themselves in relation to the roadway. Here's a chart of the mixing zone design. This is the position of every participant that rode through this design and their instantaneous lane positioning as they traversed it. They were very uncertain where to go. They didn't know where to position themselves, they didn't know where they should be in the lane, and it was kind of all over the place. If we look at the bike box, much different. We had people staying in the bike lane. They knew they were supposed to be in that lane. They knew exactly where to position themselves. Aside from those 2 participants who rode into the center of the lane, that's actually the intention of the design, is they can ride into that middle bike box and it makes them more alert, but we weren't as concerned with that. We looked at the bicycle signal as well and we saw similar results. We saw that participants tended to stay in the middle of the lane and it was very predictable of where they would be. So to summarize, we found that the bike box had the best overall safety performance. It had good responses from participants, it was very balanced across the board, and it was kind of right in the middle of the other 2 designs. The bicycle signal, on the other hand, had great performance. It eliminates that conflict, but there's always the potential for promoting bad riding habits. Think back to that eye tracking data that I mentioned. Participants were not focused on that potential conflict, and they were not aware of that vehicle. This can cause problems if this design is installed too frequently. The mixing zone was wildly diverse. It was kind of all over the place, and participants did not necessarily like that design as much. So to conclude, I think that you might see these designs pop up more and more on the roadway. And in the end, whether you're a driver, a bicyclist, or any other road user, we all have to look out for one another and keep the safety of each other in mind. Thank you.